Hello, my dear students of 0151 Fast Track College Algebra Spring 2026. We are in a journey. We start this semester with Module 0, then Module 1, and then we have also Module 2. And this week, I want to share with you guys Module 3. Module 3 is linear equations. I sent you the last week a video for the Module 2, no factoring polynomials. And today we will be working with linear equations. And this assignment is due the next Monday at 11:59. Module 3, linear equations. And always, when you come to your model, you need to open it. And when you open, you have my lesson, my lecture notes on my lesson, then it's a PowerPoint. No, and then also you have the quiz for linear equations. And if you have any question, please let me know, and I will happily help you. So I will do the video for this week, linear equations. Don't forget to take your quiz. Again, the due date is 2/10, the next Monday. The next Tuesday, 2/10 at 11:59 p.m. Let's go to our lesson today. What are linear equations? Well, linear equations are first-degree equations representing straight lines. We will be working more in deep with straight lines in the next 2 weeks because we'll be getting to graphing lines. We will working in the X and Y plane, and we will learn about slope and how to find the slope and all this stuff. But today I want to talk to you about linear equations. Again, a linear equation with one variable has a unique solution. No, in this case, I give you example: ax plus b equals 0. And a can be any real number. We can be a 3. No, and then you have a variable. We already learned about that, variables and terms in the first lesson. When I send you the video, you can go back if you want to refresh that. And then the variable could be any letter of the alphabet, 3x. No, and b is a real number too, will be plus 4 equal 0. So that is a linear equation with one variable, and we'll have one solution because let me put another number here, put 12. Because if you subtract 12 from both sides, you will have 3x is equal 12. And then when you divide both sides by 3 to isolate your x, 12 divided by 3 is 4. And that is the only solution that this equation will have. A linear equation with two variables represent a line with infinitely ordered pairs. Because in a line, an ordered pair is a solution. An ordered pair is x and a y. It's a point in the xy plane. No, that is your x, your y, x plane, and you have a point in the plane. This point have an address, have a X value and a Y value. And that is one solution because according to geometry, a line have infinitely points. A line can have 100 points, 1,000,000 points, 1,000,000,000 points, and every point is a solution for the line. And we will go more in deep about lines and order pairs in the next 2 weeks. An example of an equation is the one I have here. It's ax plus by equals 0. Because I have 3x, again, you have your coefficient, your variable, 4y, your coefficient, your variable, and then equal 5. And to solve this equation, that's in standard form. Most of the time we have to convert it in y-intercept. And when we do that, then we can find the point or the points that are the solution for this line. Forms of linear equations, the standard form, 3x plus 4y equal 5. Y-intercept form, y is equal to 3x plus 4, always, and that is, we always say that is the y is equal to m times x plus b, because m is your slope and b is your y-intercept. And then the other linear equation that we're working with is the point-slope form. Y minus y1 is equal to m times x minus x1. Well, that is the foundation of linear equations. And let's go and to solve some of these equations and have some examples. Now we need to erase what is in the wall. I'm recording this video. Then you can come back and you can study as many times as you need it. But I give you a little synopsis, a little summary of linear equations. But we will work more in deep in the next week. It's a good example, for example, I'll give you my first example of a linear equation. You have 36 minus 36x, 36x minus 64 is equal to 0. And that is a good example of a linear equation with only one variable. One variable will be x. So how we solve this equation? Well, at the first step that you have to do is you need to, in the end, in mathematics, we have some rules, traditional rules, how we express our equation, how we express an answer. And normally we have always the variable, could be the x, the y, any letter of the alphabet in the left, and we have in the right the answer that normally is a real number. Because that, the third step for this equation will be move negative 64 to the right side to try to isolate an x. Because in the end, that will look like a x is equal something. That will be the final answer. So we need to move the 64 to the other side. We have to use what is the identity property. To cancel this negative 64, I need to do the opposite equation. I need to add 64 to both sides of the equation. Because the law of equality in mathematics says that what you do in one side of the equation, you should do it in the other side to don't change the equation. Says I need to add 64 to this side of the equation too. When I do that, this negative and positive cancel, And I have now that 36x is equal to 64. Now I have still a number multiplied to x, 36. So to be able to isolate my x and get my final answer, I have to again do my opposite equation. What is the opposite of multiplication? Because 36 is being multiplied by x. So the opposite equation will be divided by 36. Both sides by 36. And when I do that, these cancel, and my final answer is x is equal to 64 over 36. But the point, that is the answer, but it's not the final answer. Remember, every time that you submit an answer to me or to your homework, when you do a MATLAB, they will request that you submit an answer in the lowest terms. And I can still simplify this question. No? I can divide both sides by 4 because 4 is a LCM, the least common multiple of both, and can divide both evenly. So if I want to divide 64 by 4, will be a 16, and I divide 36 by 4 is a 9. No, and then my final answer is that x is equal to 16 over 9. There is nothing else I can do because there is not a number that can divide evenly 16 and 9. So that is my final answer. I stop there. Let's do example number 2. No, example number 2 also have only one variable. Let's do this equation. You have example number 2. You have 2 that is multiplied by, in parentheses, you have 4y minus 1 equals 13. So following PEMDAS, my first order operations would be to distribute 2 inside of what is in the parentheses, a positive 2. So let's do that. No, positive 2 times positive 4y is 8y. Remember, when we multiply in monomials or polynomials, we multiply only the numerical part, and we carry on the variable. And then positive 2 times negative 1, positive times negative is a negative, will be a negative 2, and then that is equal to 13. So my next step is, again, I need to isolate my y because I'm solving for y. In this second example, y is my variable. I will then, first of all, add 2 to both sides to move these 2 to the other side of the equation. And when I do that, these 2 cancel. And I have ay is equal to 15. And then finally, to be able to solve for y, I need to divide both sides by 8. And remember, what I'm doing is the identity property. You do the opposite. You have a negative 2, you add 2. You are 8 being multiplied by y, you divide by 8, the opposite equation. And you do in one side of the equation, you have to do in the other side. That is the law of equality in mathematics. So these 2 cancel, and I have that y is equal to 15 over 8. And again, there is no a number can divide evenly 15 and 8. That will be my final answer. Let's keep doing more examples. Want to be sure you have plenty of examples. Let me erase that carefully. Let's do example number 3. Example number 3, I have 5a plus 3 is equal to negative 4a plus 4. So now we have variables on both sides of the equation. As I said before, it's a tradition in mathematics that when you write an answer for an equation of one or two variables, always the one variable that you are solving have to be in the left, and then the answer is in the right. So in the left side of the equation, we should only have a, and in the right side of the equation should be the answer. So first of all, I will combine like terms. I have a negative 4a and in the right, and a 5a in the left. I will add 4a to both sides to move this 4a to the other side. 4a. It looks like a 4, yeah. So when I do that, the negative 4a and positive 4a cancel. And now I have 9a, no, plus 3 is equal to 4. No, 9a plus 3 is equal to 4. But again, because I need to solve for a, and I need to isolate this a, I will move my 3 to the other side of the equation, from the left to the right. To do that, I will subtract 3 from both sides. When I do that, the positive and negative 3 cancel. I have now 9a is equal to 1, because positive 4 minus 3 will be 1. And finally, to solve for a, because this a is being multiplied by 9, I will divide this by 9, both sides, and this 9 in the numerator, they will cancel. And my final answer is that a is equal to 1, 9. So you can see, because we have equations with only one variable, we always have only one solution, what I mentioned in the opening of this lesson. Let's do example number 4. Example number 4, I have a 4a minus 5 is equal to 3a plus 1. Again, and I will combine like terms. I will move my 3a from the right to the left. To do that, I will subtract 3a from both sides. When I do that, this positive 3a and negative 3a cancel. And now I have a positive 4a minus 3a, that will be a only. And then I have minus 5 is equal to positive 1. Then to solve this equation, I will move this negative 5 to the right side. To do that, I will add 5 to both sides. And I ended that a is equal to 6. You have a positive 5 plus 1 is a 6. As you can see, again, we are doing these steps, and we are doing this over and over in order you can understand how to solve these equations, how to find the answer, and the process of the equation. And I explain why we're doing everything. The next equation, let me go to another to find more examples. Okay, let's do this one with fractions. I have 3x minus 1/2 is equal to 1/6. Sometimes when we see fraction, we get intimidated, but in reality, is the same process that we did when we were doing fractions in middle school. First of all, because even if I move my 1/2 to the other side, if I add 1/2 to both sides, and I move my 1/2 here, will be plus 1/2. I cannot add or subtract these two fractions because have different denominators. Remember, the only way that you can add and subtract fractions is that you have both fractions have the same denominators. When you multiply and divide fractions, you don't have to worry about that. But when you add or subtract, both have to have the same denominator, and they are not having the same denominator. So before do all this stuff, the first thing I will do is I will find my LCD or LCM, my least common divisor, or the least common multiple. And between 6 and 2, my 2 is a multiple of 6, and 6 is a multiple of itself. So I can say that 6 is my, the number 6 is my number 6 is my least common multiple. I want to illustrate why I said that. How you find your LCM. You put your 2 and your 6. And you begin to multiply each one of these numbers by 1, and at the same time, by 1, by 2, until you have a number that appear in the line of the 2, and the multiples of 2 and the multiple of 6 the same. So it's less to 2 times 1 is 2, and 6 times 1 is 6. 2 times 2 is 4, and 6 times 2 is 12. And 2 times 3 is 6. And I stop there. Or you can go 6 times 3 is 18. And you stop there because you was able to find a number that is the same or repeat in both lists. In the list of the multiples of 2, you have a 6. And in the list of the multiples of 6, you have a 6. So that is the reason I said 6 is my LCM, my least common multiple. And that is the number that you need to multiply everything in this equation. That is the way that you find your least common multiple. Again, and recording, you can come back and check this again. So I will start first of all and multiply 6 over 1 times 3 over 1, and I'll put my x outside. Then minus, I'll put my bracket again, 6 over 1 times 1/2. There is no variable there. And then equal, and I will do the same thing. It will be bracket, I'll put my 6 over 1 times 1 over 6. So you see, I multiply everything in this equation by my LCM, my least common multiple. So what are we doing next? Well, I will begin to simplify. 6 times 3 is 18. And I need to carry my x minus. Before multiply, I will simplify. How many times 2 go into 1? And now I don't have no denominators, but 2 go 3 times and 3. So you see minus 3 equals, and then 6 in the numerator, they will cancel, and these 2, and the only thing I have is 1 here. So you can see I start with 2 fractions, and now I have a straightforward equation, a linear equation. And the first thing I will do, I will move my 3 to the other side. You have use a negative 3, I will add 3 to both sides. Plus 3. And then you have that 18x is equal to 4. And then what we'll do is I will divide both sides by 18 to isolate my x and find my solution. No, and the final answer is that 18 is equal to 4 over 18. But again, that is not my lowest terms. I can still divide both sides of the equation by 4. No, let me think. No, I can divide it by 2. No, 4 divided by 2 is a 2, and 18 divided by 2 is a 9, and that will be my final answer. As you can see, we have only one answer because we are working with equations that have only one solution. Let me keep going, more examples of these ones, of fractions, that you have things to practice and understand how you work these equations and why. So let's do the next one. You have a x over 5, no, plus 2, 4, and that is equal to negative 6, 4. Now we have three fractions, no? And what we do the same thing. We found an LCM, no? An LCM stands for least common multiple. And if you put a 5 and you put a 4 and you make a list of each one of their multiples, you multiply both by 1. 5 times 1 is 5. 4 times 4 is 4. By 2, no, 5 times 2 is 10. And 4 times 2 is 8. By 3, 5 times 3 is 15. And 4 times 3 is 12. No? And then you multiply both by 4. 4 times 5 times 4 is 20. And then 4 times 4 is 16. We don't have two numbers that appear in both lists. And 5 times 5 is 25. And 4 times 5 is 20. And you stop there because you find your least common multiple. 20 appear in the list of multiples of 4, but 20 also appear in the list of multiples of 5. And that is my LCM, will be 20. So I have to multiply everything in this equation by 20. So I start 20 over 1 times, and remember, we know that there's a 1 there because the default coefficient for any variable is 1, and the default power is 1. So there is a 1. So I can multiply 20 over 1 over 1 over 5, close my bracket, and put my x outside. That will be part of the answer. Plus 20 over 1, again, open my bracket, times 2 over 4, 2 over 4. And then that is equal, don't forget your negative sign, no? And then you have 20 over 1 times 6 over 4. And now I simplify each one of the brackets. How many times 5 going 5? 1. There is no more denominator in this equation. How many times 5 going 20? 4 times. So the only thing I have left over in this bracket will be 4 times 1 times x. That will be 4x. I drop my plus sign and do the same thing with the next bracket. How many times 4 and going 4? 1 time. There's no more denominators. How many times 4 going 20? 5 times. So the only thing I have left over in this equation will be 5 times 2. That is 10. Put my 10 there, my equal, and then don't forget your negative sign. Negative. And then I will do the same thing in the third bracket. How many times 4 going 4? Once. No more denominators. How many times 4 going 20? 5 times. And the only thing I have is 5 times 6, and that will be 30, negative 30. Because I have 4x plus 10 is equal to negative 30. And in the process to find my answer, I need to isolate this x. The first thing I will do is move 10 to the positive 10 to the other side. To do that, I will subtract 10 from both sides. When I do that, the positive 10 and negative 10 cancel, and I have now that 4x is equal negative 10 times negative 30. Remember the law of signs? When you have two negatives, it's like you are adding these two numbers together, and the answer will be negative. Negative 10 minus negative 30 will be negative 40. And then finally, I will divide both sides by 4. When I do that, this 4 here cancel, and x will be equal negative 40 times positive 4 will be a negative 10. When you divide a positive and a negative, the answer is negative. And that was the final answer of this equation. Again, I'm going step by step in order to you understand what I'm doing, how I'm doing, no? And you can learn how to solve your equations when you are in your assignment. Let me do one or two more. We have time for two more. And then this video will be up exactly in an hour when I finish my next class. So the last one I want to do is x over 2, no, minus x over 4 is equal to 5. Again, I need to find my least common multiple. My least common multiple. I have a 2, and then I have a 4. 2 times 1 is 2, 4 times 1 is 4. 2 times 2 is 4. There's a 4. And 4 times 2 is an 8. And I stop there because 4 is in the list of multiples of 2, but also is in the least multiple of 4. That is my LCM, my least common multiple. So I multiply everything in this fraction by 4. But if you want to multiply, another way to do it is multiplying the two denominators. I will give you 8. Let's do an 8 this time. But 4 worked perfectly. But let's try an 8. You can see that if you multiply the denominators, or you find the LCM, you end in the same answer. So you have 8 over 1 times, remember there is a 1 in front of this x, so it's times 1/2. I put my x outside. Then I will carry on with my answer, drop my negative sign, and then open my bracket here. It will be also 8 over 1 times, there's a 1 there, will be 1 or 1/4, and I put also my x here. And then finally, I will have 5, no, over 1. If you want to put over 1 times 8 over 1, no. And then let's clean up every bracket. The first bracket, how many times 2 going 2? 1 times, and 8, they go 4 times. So I have 4 times 1 times x will be 4x minus. How many times 4 going 4? 1 times, and 8 go 2 times. So the only thing I have left over is 2 times 1 times x. That will be 2x. And here, 5 times 8 is 40. So now I have a straight equation. But what we do now, I will simplify like terms. You have 4x minus 2x. That is a positive. You know, when you subtract two numbers with different signs, you carry always the sign of the bigger number. Who is bigger, 4 or 2? 4. So the answer will be positive. Then you subtract 4 minus 2 is a 2x is equal to 40. And then finally, I will divide both sides by 2. So my final answer is that x is equal to 20. So you can see we are consistent in what we are doing. We are consistent. Let me do last one. This last one have decimal. Listen, when you work with decimals, you have two options. Number one, you are good in arithmetic, keeping decimals, but if not, multiply every decimals by 10 and you have a whole number. 0.9x, no, minus 0.3 is equal to 0.6. What I said is you can multiply everything by 10. If you multiply both sides by 10, and this by 10, you will have 9, negative 9. So negative 9 minus 3 is equal to 6. But if you are good in arithmetic and you don't want to do that, you can continue in using decimals. Because again, to solve this equation, I need to move the 0.3 to the other side. I will add 0.3 to both sides. This positive and negative cancel. And I have a negative 0.9 is equal to 0. Is equal to, and I get lost myself. Positive. Oh, that is a negative sign. It's a negative 0.6. I forgot something. Okay, so you have a positive 0.6 and a negative, negative 0.6 and a positive 0.3. The answer will be 0.3. You subtract and you are doing any number. But again, if you are uncomfortable to do in decimals, multiply both sides by 10 and do the same process. Then and I forgot my x here. Let me do this better because 0.9x. Okay. Just to find my final answer, I need to divide both sides by negative 0.9. And I divide this by 0.9. If you don't know how to do that, please use your calculator. No? And the final answer is x is equal to 1/3. So that is the video for today. I hope that you enjoyed as I enjoyed. I give you examples of everything that you will see in your equations. Also, I will add to this assignment my same Microsoft document with all the examples. So you have a video that will match exactly my lecture notes. Well, that is all for today, students. We have learned today about linear equations. If you have any problem or need any help, please shoot me an email and I will happily assist you. Until the next video, have fun and be safe. Terry, I will give you extra credit to be in my class, but remember, when you are in my class, you need to have your camera up all the time. I will save you this time, Terry, but
Okay.
next time your camera has to be up.
Okay, I'm sorry about that. I didn't know if we were supposed to have it on or.
Yeah, but I will give you the credit for your attendance. I will give you
Okay.
extra points for every Tuesday that you are in class in this video.
Okay, thank you.
So you're welcome. See you in class.
Okay, see ya.
Okay, bye-bye.